Hello students, I am Rakha Choudhary madam from R.N. Patil Girls High School, Neminath Nagar, Sangli. Today we are continuing the third chapter, Current Electricity. Electric circuit. A continuous path of an electric current through conducting wires connected to the two ends of a cell and other resistances is called an electric circuit. This figure shows how different components are to be connected in the circuit by using the special symbol for each of the components. Such a figure is called an electric circuit diagram. In the circuit, an ammeter is used to measure current and a voltmeter to measure the potential difference between the two ends of the resistor. As the voltmeter has a very high resistance, only very small current flows through it. Students, point out the mistakes in the figure above. See first figure, here circuit is not completed because wire is breakdown. Then in second figure, circuit is not completed, still bulb is on. In third figure, circuit is completed but bulb is off. And in fourth figure, piece of rubber is connected which is insulator, still bulb is on. It is the mistake. Then why are the bulbs in the figure B, C and D below not lighting up? See, here circuit is not completed in B figure, so bulb is not lighted. Then in C figure also circuit is not completed, and in D figure both the wires are connected at one pole of the cell, so circuit is not completed and bulb is off. Symbols for components of an electric circuit and their uses. First component, electric cell. See the picture. Then symbol is like this. Used to apply a potential difference between two ends of a conductor. Then second component is battery. Here collection of number of cells. See, battery is like that, like this. Symbol is like this. Then use is to apply a larger potential difference between two ends of a conductor. Third component, open tap key or plug key. Picture is like this and symbol is like this. Use to stop the flow of current flowing in a circuit by disconnecting two ends of a wire. Component closed tap key or plug key. Picture, symbol, to start the flow of current in a circuit by connecting two ends of a wires. Next component, connecting wires. That is, picture is like this. Then symbol, to connect various components in the circuit, wires are used. Then crossing wires. Picture is like this. Symbol. Then to show wires which cross but are not connected. These wires cross each other but not connected to each other. Then lightning bulb or light bulb. Picture is like this. Symbol C. This is lighted bulb and this is off bulb. Used to test the flow of electricity, that is lighted. Current is flowing, unlighted current is not flowing. Okay. Then resistance. Picture is like this. Symbol is like this, to control the flow of current in the circuit. The next component, variable resistance. Picture is like this and symbol is like this. Use to change the resistance as required and thereby control the current. Next, ammeter. Symbol is like this, to measure the current flowing in the circuit. Then voltmeter. Picture, symbol, and uses to measure the potential difference between two points in the circuit. Conductors and insulators. We can divide substances into conductors and insulators. Insulators means bad conductors. Conductors, those substances which have very low resistance, are called conductors. Current can flow easily through such materials. Then insulators. Those substances which have extremely high resistance and through which current cannot flow are called insulators. Examples on Ohm's law and resistivity. The resistance of the filament in a light bulb is 1000 ohm. If the bulb is fed by a current from a source of potential difference 230 volt, how much current will flow through it? Given R is equal to 1000 ohm. That is resistance is 1000 ohm. Then V is equal to 230 volt. That is potential difference 230 volts. Then according to Ohm's law formula, I is equal to V upon R. So I is equal to 230 volt upon 1000 ohm is equal to 0.23, and it is electric current, so unit is ampere. So 0.23 ampere. The current flowing through the filament of the bulb is equal to 0.23 ampere. System of resistors and effective resistance. A resistor is a two-ended component having a given amount of resistance between its two ends. In several electric devices, a number of resistors are connected together in different ways. Ohm's law is applicable to all such connected series. See the figure. You can see that the ends of the three resistors are connected so that they follow one after the other in a single line. These resistors are said to be connected in series. In such an arrangement, the same current flows through each resistor. The value of current is I and the potential difference between C and D is V. The three resistors R1, R2 and R3 are connected in series in a circuit. Let the voltages across them be V1, V2 and V3 respectively. Then V is equal to V1 plus V2 plus V3. This is the equation 1. If RS, S for series, is the effective resistance between C and D, then according to Ohm's law, V is equal to I into RS. Then V1 is equal to I into R1, V2 is equal to I into R1 and V3 is equal to I into R3. Substituting all these in equation 1, we get I into RS is equal to IR1 plus IR2 plus IR3. Then dividing by I on both the sides, RS is equal to R1 plus R2 plus R3. If n resistors are connected in series, then RS is equal to R1 plus R2 plus R3 plus dash 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 Rn number of resistors. If resistors are connected in series, the same current flows through each resistor. The effective resistance of the resistors is equal to the sum of their individual resistance. The potential difference between the two extremes of the arrangements is equal to the sum of the potential differences across individual resistors. The effective resistance is larger than each of the individual resistances. This arrangement is used to increase the resistance in the circuit. See students, solved example for resistors in series. First example, 3 resistors having resistances of 15 ohm, 3 ohm and 4 ohm are connected in series. What is the effective resistance in the circuit? Given R1 is equal to 15 ohm, R2 is equal to 3 ohm, R3 is equal to 4 ohm. Effective resistance RS is equal to R1 plus R2 plus R3, that is 15 plus 3 plus 4 is equal to 22 ohm. So the effective resistance in the circuit is equal to 22 ohm. Resistors in parallel. Resistors are said to be connected in parallel when their ends are connected at both the sides as shown in the figure. The figure shows 3 resistors R1, R2 and R3 connected in parallel between points C and D. V is the potential difference between C and D. Let I1, I2 and I3 be the currents flowing through R1, R2 and R3 respectively. Then the total current flowing through the circuit is I is equal to I1 plus I2 plus I3, equation 1. Let Rp, P for parallel, be the effective resistance between C and D. According to Ohm's law, I is equal to V upon Rp. Similarly, I1 is equal to V upon R1, I2 is equal to V upon R2, I3 is equal to V upon R3. Substituting these values in equation 1. V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. So 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If n resistors are connected in parallel, then 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R, a number of resistors. If a number of resistors are connected in parallel, first the inverse of the effective resistance is equal to the sum of inverses of individual resistances. The current flowing through an individual resistor is proportional to the inverse of its resistance, and the total current flowing through the circuit is the sum of the currents flowing through the individual resistors. The potential difference across all resistors is the same. The effective resistance of resistors connected in parallel is less than the least resistance of individual resistors. This arrangement is used to reduce the resistance in a circuit. Then precautions to be taken while using electricity. Students, you should take precautions like this. First, electric switches and sockets should be fitted at a height at which small children cannot reach, and put pins or nails inside. Plug wires should not be pulled while removing a plug from its socket. Before cleaning an electrical appliance, it should be switched off and its plug removed from the socket. Third, one's hand should be dry while handling an electric appliance, and as far as possible, one should use footwear with rubber soles. As rubber is an insulator, it prevents the current from flowing through our body, thereby protecting it. And last, if a person gets an electric shock, you should not touch that person. You should switch off the main switch, and if the switch is too far or you do not know where it is located, then you should remove the plug from the socket if possible. If not, then you should use a wooden pole to push a person away from the electric wire. Thus, we have completed the lesson. Read the lesson and solve the exercise.